All right, this is derivatives day 3. We're just going to keep taking what we've been doing with the difference quotient and derivatives, kind of that left box, right box discussion, and we're just going to do a couple more examples. So this first one is just our basic square root of x function, which you've graphed a bunch of times, starts at 0, 0, and kind of wings out there. So we're just talking about trying to find the slope at any time or between 2 points. So again, remember just difference quotient and derivative, everything we're doing is just about slope. So the two functions you need to start with are f of x and then f of x plus h. So our two functions will look like that. So to find the difference quotient, we are going to use our formula f of x plus h minus f of x all over h. So I'm going to take my two functions. First up is f of x plus h, and we're going to subtract square root of x. So that's our f of x plus h minus our f of x all over h. Actually, I don't need an equal sign. There's not really anything else I can do to that. There's nothing that can simplify. There's nothing that goes together. So that's the best that is going to get. So that is our difference quotient. What is the average velocity from 1 to 4? Average velocity is left box, just like difference quotient is in the left box, which is convenient because I have two variables, an x and an h, and I have two numbers, a 1 and a 4. So I'm going to pick an x. I'm going to pick the 1. And then remember, your h is your space from one to another. So h is going to be 3. And I don't think I can squeeze it in there, so I'm going to come over here. So I'm going to take this, and I'm going to plug a 1 in where the x is. And I'm going to plug a 3 in where the h is. And 1 plus 3 is 4. Square root of 1 is 1 all over 3. So square root of 4 is 2 minus 1 all over 3. Looks like our slope is a third. So if I were to look from 1 to 4, it looks like it's kind of shallow, up 1 over 3. That seems plausible, so that's pretty good. Next one says find the derivative. That is a right box item, which means no h's, which means you just take your difference quotient, and we're going to let the h's go to 0. Problem is, as soon as I plug in a 0 here, I'd have square root of x minus square root of x. That would be a 0. If I plugged a 0 in here, I'd have a 0, which would mean I'd have 0 over 0, and that's called the indeterminate. Thankfully, we've already dealt with things like this before. We did it with limits. So we're going to multiply by the conjugate, which is square root of x plus h plus square root of x. And you have to do the same thing on the top and the bottom. And now we're going to FOIL. And remember, the nice thing about foiling conjugates is lots of it cancels. So I have square root of x plus h times square root of x plus h. That will give me just x plus h. The roots will cancel. And since we're doing conjugates, the outside and the inside will cancel each other, so the last thing I have to do is negative square root of x times positive square root of x, which is just negative x. All over h, and remember, we don't really want to multiply these things together. We don't want to distribute that h in there because we're hoping it cancels. So it looks like my x and my negative x cancel, and then my h and my h. So I'm left with the limit as h approaches 0 of 1 over x plus h plus square root of x. So now if I plug my 0 in there, I've got 1 over square root of x plus square root of x, which is totally fine. You can also write 2 root of x. That would kind of simplify things a little bit for us. Whoops, I ran out of time. Next question says, can you find the instantaneous velocity at 4? That's a right box question, so no h's, which is helpful because I only have one number, so I have to use an equation that's only got one variable. So we're just going to plug a 4 in there, 1 over 2, and then root 4, and I know the root 4 is 2, so it looks like my answer is 1/4. Excuse me. Next up, we've got find the slope using the difference quotient. So I'm going to write out my second function, which is f of x plus h. Oops, negative 2x plus h plus 4. And remember, these are the two functions I'm just going to subtract. I'll write it out for you, x plus h minus f of x all over h. Subtract the 2, so negative 2x plus h plus 4 minus our function all over h. Let's do a little simplifying, so I'll distribute my 2. I will distribute this negative. And remember, at this point, everything that does not have an h should cancel. So I've got negative 2x, positive 2x. I've got a positive 4 and a minus 4, so I'm left with negative 2h over h, which cancels as well, and I have a negative 2. And you're like, how can that be? But remember, we were just finding slope, and this is the equation for a line, y equals mx plus b. So we already knew our slope would be negative 2. Just kind of showing you that the difference quotient does hold true, that the slope will be -2. This was just a line, so the slope will never change. So our answer is -2. Next one, a little more convoluted. So here's my f of x plus h. I got some squareds in there, so I'm going to have to do a little bit more work. Throw my x plus h's in where they belong, so it looks like I'm going to have a FOIL here. So doing f of x plus h minus f of x all over h. So we're going to subtract the two. So -8 x plus h plus 4 x plus h squared, and then we're going to subtract our function. So -8 and 4x squared all over h. So this first part, I'm going to distribute my 8 plus, and we FOIL this one all the time, so that comes out to be x squared, 2x h's, and an h squared. So I'm going to distribute my 4 right into that. And I'm going to distribute my negatives, so 8x and a minus 4x squared. Reminder again, when you get to this stage and everything is all multiplied out, you should be able to cross off everything that does not have an h. So I got -8x and I've got a positive 8x. I've got a 4x squared and a negative 4x squared, leaving me with -8h plus 8xh plus 4h squared all over h. Everybody loses 1. So we have -8 plus 8x plus 4h. Remember, this is your difference quotient, your DQ, and it is, again, just finding you slope, and it'll do slope between any 2 points you give it. We only have 1 point at the point, which means we're a right box question. So I take that and I essentially just get rid of the h's. So my derivative is -8 plus 8x, and those h's are gone. So this is my derivative, and all I have to do is plug in my 1 point. Remember, this is an x and a y, and I am only plugging the x value in. So I'm going to put an x right there. -8 plus 8 times -2, which is -24. Pretty steep slope, a negative slope. And one more to go. It says find the slope of any tangent line. That's a right box question to this graph. So right here I don't have any numbers to plug in, which means, not like this one where I had a number to plug in. So since I don't have any numbers to plug in, what you're going to give me back for an answer is an equation, is the equation for the derivative. So let's get our other function, x plus h. We're going to subtract the 2. So bottom minus the function all over h. Some FOILing to happen here. Again, we've done this one a lot. Comes out the same every time. Distribute your negative, and everything without an h should cancel, and it does, so we know we did it right. 2xh plus h squared over h. Everybody's going to lose 1. And that is my difference quotient. If I want my derivative, which is where we are because we're in the right box, I just get rid of the h's. So this said, what is the slope at -1, 2? This is an x and a y. This is technically 1 point. So I just take my x and plug it right in. 2 times -1 is -2. Same with this one. I've got just 1 point again. This is an x and a y, and I don't care about the y. So I just take the 2, plug it in. 2 times 2 is 4. So I have found that what works best for students is to make sure that you see the function and then you do it with an x plus h. And those are the two things you're going to subtract, kind of set them up there. Missing this distribute is kind of a big mistake for students. They forget to distribute that negative all the way through. So maybe kind of exaggerate it so you see it, that it needs to distribute.